Hello everyone. In this video, we will be studying about the angle of friction, the angle of repose, and the cone of friction. Firstly, the angle of friction. The angle of friction is represented by the letter or the symbol phi. So this I would like to explain with an example. So here we have considered a block of cell phi W and a force P is applied towards right direction, which tends to move the block towards right direction. So with respect to this, an opposite frictional force will be developed at the contact surface and a normal reaction will be developed in the vertically upward direction. So as I said earlier, R represents the resultant force due to the frictional force and the normal reaction. So here the angle of friction is nothing but the angle between the resultant force R and the normal reaction that is developed at the contact surface. So that is represented as phi. So how to determine this phi value? So I'll consider this triangle ABD. So wherein tan phi will be given by AD by AB. So AD is representing nothing but the frictional force F and AB represents the normal reaction N. So tan phi will be equal to F by N, which in turn is equal to the coefficient of friction mu. So this is all about the angle of friction. Okay, now let us study about the angle of repose. So when a plane is inclined to a horizontal by a certain angle, the body placed on it will remain at rest up to a certain angle of inclination, beyond which the body just begins to move. This maximum angle made by the inclined plane with the horizontal, when the body placed on it, the plane is just at the point of sliding down the plane, is known as angle of repose. Now, as per the statement, this is our horizontal plane and this is our inclined plane, so which is inclined to the horizontal at an angle theta. So on this inclined plane, a block of self weight W has been placed. So this angle of inclination theta, now I will consider it as 20 degree. So at this angle the body does not slides down. Now I will increase this theta to 25 degree. Even at this angle the body does not slides down. Now I will increase this theta value to 30 degree. Even at this stage the body does not slides down. But now I will increase this angle to 31 degree. So at this stage I can observe that the body starts sliding down. So here the maximum angle which can be considered such that the body does not slides down is equal to 30 degree. Why? Because as soon as I increase to 31 degree, the body starts sliding down. So as per the statement, the maximum angle made by the inclined plane with the horizontal. So here the maximum angle is 30 degree when the body placed on that plane is just at the point of sliding down the plane. So that means at 30 degree it is just at a point of sliding down the plane. So here the angle of repose theta is equal to 30 degree for this case. So here in the figure you can observe the W, that is, it is always acting vertically in the downward direction irrespective of the inclination of the block. This is very important, which has to be considered. So this is all about the angle of repose. Okay, now let us study about the relationship between the angle of friction, that is phi, and the angle of repose, that is theta. So now I'll be considering this same figure. So wherein a block has been placed on an inclined plane which is inclined to the horizontal plane at an angle theta. So the self weight of this block will be acting always vertically downward direction. That is, this is always a straight line which is perpendicular to this horizontal plane. So now I'll consider this inclined plane as my x-axis and this perpendicular line as my y-axis. So here if you observe, the angle between W, that is self weight, and the y-axis is mentioned as theta. So that is which is equal to the angle of repose. So how this is occurring? So okay, I would like to explain this with the figure on the right hand side. So if you observe here, we know that the angle between the horizontal plane and this inclined plane is theta. So I have extended this self weight line so that it touches the horizontal line over here. So as it is perpendicular, this will be equal to 90 degree. Now the angle between the x-axis and this self weight is represented as alpha. So alpha now will be equal to 90 minus theta. So here I will consider the opposite angle which is equal to alpha. So alpha will be equal to 90 minus theta degree. And now I know that the angle between x and y axis is 90 degree. So this remaining angle becomes 90 degree minus alpha, which in turn will be equal to theta. Now coming back to this figure. So how to find out the relationship between the angle of friction and angle of repose? So for this above figure, we will be applying the condition of equilibrium along the horizontal plane, that is x-axis, and vertical plane y-axis. So now you must be very careful here. When I consider this x-axis or y-axis, it is the x and y-axis which is with respect to this particular block only. So now along x-axis, that is sigma fx is equal to 0. So which are all the forces acting along x-axis? So one is the frictional force F and the other is the self-weight component along the x-axis. So resolving the forces along x-axis, minus F plus W sine theta will be equal to 0. So F will be equal to W sine theta. So this I will consider as equation 1. Now resolving the forces along y-axis. So which are all the forces acting along y-axis? One is the normal reaction and the other is the component of the self weight along the y-axis. So that is n minus w cos theta equal to 0. So which is n equal to w cos theta. So now we know that mu, that is coefficient of friction, is equal to F by n. So F by n, that is dividing equation 1 by equation 2, I can say it as F by n is equal to W sine theta by W cos theta, which is equal to mu equal to W sine theta by W cos theta. So sine theta by cos theta, we know that it is equal to tan theta, where W get cancelled. So we know that phi is equal to F by n, wherein F by n is equal to tan phi. So tan phi will be equal to tan theta. So tan get cancelled, wherein phi is equal to theta. So that is angle of friction is equal to angle of repose. So this is all about the relationship between the angle of repose and the angle of friction.